The story of the universe is, above all, a story of expansion. It is a tale written in the language of light, inscribed in the faint whispers of starlight that have traveled unimaginable distances to reach our telescopes here on Earth. For most of human history, we believed our universe was static, fixed and eternal, with stars and galaxies scattered like jewels on a velvet backdrop. But in the past century, a revolution has unfolded, driven by a phenomenon known as redshift, a shift in the frequency of light that offers compelling evidence that our universe is, in fact, expanding. Redshift, in its essence, is a stretching of the wavelength of light. Much like the sound of a siren changes pitch as an ambulance speeds past, an effect known as the Doppler shift. The light from distant galaxies is stretched toward the red end of the spectrum as they move away from us. This shift is small for objects close by, but for the most distant galaxies and quasars, the redshift is pronounced and unmistakable. To fully grasp the significance of redshift, let us journey back to the early 20th century, when astronomers first used powerful telescopes to peer deeper into space than ever before. Edwin Hubble, an American astronomer, played a pivotal role in transforming our understanding of the cosmos. With careful measurements of galaxies far beyond our own Milky Way, Hubble discovered a remarkable relationship. The farther a galaxy was from Earth, the more its light was redshifted, and therefore, the faster it was moving away from us. This pattern was not random. It suggested a universe that was not static, but expanding in all directions. This relationship, now known as Hubble's law, is simple yet profound. It can be stated as follows. The velocity at which a galaxy moves away from us is proportional to its distance from us. In other words, the universe is expanding, and every part of it is receding from every other part, like raisins moving apart in a rising loaf of bread. This was a stunning conclusion, one that overturned the foundations of astronomy and hinted at a beginning, a moment when all matter was compressed into an unimaginably small, hot, and dense point. But what exactly causes redshift? On its most basic level, it's a consequence of motion and the stretching of space-time itself. There are three types of redshift recognized in astronomy. The first is Doppler redshift, which, like the ambulance analogy, is caused by an object moving away from the observer. The second is gravitational redshift, which occurs when light climbs out of a strong gravitational field, losing energy and shifting to longer, redder wavelengths. The third, and most important for our understanding of the expanding universe, is cosmological redshift. This type arises from the expansion of space itself, not just the movement of objects through space. Imagine a grid printed on a rubber sheet, with galaxies represented as points on the grid. As you stretch the sheet, the distance between every point grows, not because the points themselves are moving, but because the space between them is increasing. Light traveling through this expanding space also stretches, and as it does, its wavelength grows, shifting toward the red end of the spectrum. Thus, cosmological redshift records the stretching of space itself, a direct signature of the expanding universe. The evidence from redshift is overwhelming and comes from many different fronts. Observations across the electromagnetic spectrum, visible light, infrared, radio waves, and even X-rays show consistent patterns of redshift among distant galaxies. The most distant objects, those that formed when the universe was young, often have the largest redshifts, meaning that we see them as they were billions of years ago, their light stretched by the expansion of space over eons. The discovery of the expanding universe, rooted in measurements of redshift, also finds support in the cosmic microwave background, the faint afterglow of the Big Bang itself. This cosmic background radiation is perfectly isotropic and carries the imprint of a universe that was once much hotter and denser than it is today. As the universe expanded, this radiation cooled and stretched, its peak wavelength lengthening into the microwave region of the spectrum. Today, it serves as a snapshot of the universe just 380,000 years after its birth, further confirming that cosmic expansion has been ongoing since the beginning. The implications of redshift are far-reaching. Most importantly, they give us a timescale for our universe. By measuring the rate of expansion, the Hubble constant, we can estimate the age of the universe. The current consensus, based on a multitude of measurements and methods, is that our universe is approximately 13.8 billion years old. The redshift of distant galaxies allows us to look back in time, glimpsing the universe as it appeared at various stages in its development. Redshift also tells us about the fate of the cosmos. If the universe is expanding now, what will happen in the future? Will it continue to stretch out forever? Or might it slow down, eventually reverse, and collapse in a big crunch? Recent measurements, including observations of a particular kind of exploding star called a Type Ia supernova, have revealed that the expansion is not just continuing, it is accelerating. Distant supernovae appear dimmer than expected, their light more redshifted, a sign that some mysterious force, dubbed dark energy, is driving galaxies apart at an ever-increasing rate. This discovery, announced in the late 1990s, won the Nobel Prize in Physics and added a new twist to our understanding of redshift as evidence of cosmic expansion. The saga of redshift continues to unfold as we build ever more powerful telescopes and detectors, peering further back in time and space. The James Webb Space Telescope, for example, is capable of detecting the faint glimmers of the first galaxies, deep in the infrared, their light stretched to extremes by the expansion of the cosmos. Each new observation adds another chapter to our cosmic story, revealing galaxies assembling, stars igniting, and mysteries taking shape in the darkness. Beyond the technical details, the narrative of redshift and the expanding universe reshapes our place in the cosmos. It tells us that the universe is a dynamic, evolving entity with a history and a future. The galaxies we see today have not always been as they are. The stars within them are born, live, and die, scattering their elements across space to seed new generations of stars and planets. We, ourselves, are made of the products of this cosmic evolution, atoms forged in the hearts of long-dead stars, scattered across billions of light-years by the inexorable expansion of space. For centuries, humans gazed at the night sky, convinced that they stood at the center of a changeless universe. Redshift shattered that illusion, revealing instead that we inhabit a universe in motion, a universe that began in a fiery explosion and has been expanding ever since. Every beam of starlight that reaches our eyes is a message from the cosmos, stretched and redshifted by the long journey across a universe in flux. Redshift is not just a technical term, a mere shift in wavelength. It is the signature of the grandest story ever told, the birth, growth, and future of everything we know. It connects the local to the cosmic, the familiar to the unimaginable. Through patient observation and relentless curiosity, astronomers have transformed redshift from an abstract concept into a cornerstone of modern cosmology. As we contemplate the expanding universe, we find ourselves faced with profound questions. What is the nature of dark energy, the mysterious force accelerating the cosmos? What happened in the first moments after the Big Bang? Are there other universes beyond our own, forever hidden beyond the horizon of our observations? These are questions that redshift, and the evidence it provides, shapes and refines. The expanding universe, revealed by the redshift of distant galaxies, stands as one of humanity's greatest discoveries. It requires us to rethink time, space, and our own significance against the backdrop of billions of galaxies. It challenges us to reach further, to build new instruments, to ask deeper questions. We are, all of us, participants in this expanding cosmos. The redshifted light that fills the night sky is a bridge to the past, a record of ancient events playing out on cosmological scales. By measuring these shifts with increasing precision, we unlock secrets of creation and destiny. The universe expands, and so does our understanding, propelled by the faint but persistent clue of redshift, proof, in every wavelength, that we are part of a journey that began billions of years ago and continues to unfold with every passing moment. Thus, the evidence from Redshift is not only a scientific fact, but a call to wonder. It is an invitation to look up and realize that the universe itself is alive with change, that every photon is a time traveler, and that in studying the widening gulf between galaxies, we come to grasp the ever-widening horizon of human knowledge. The expanding universe beckons, and through the signpost of Redshift, we press onward into the depths of space, ever curious, ever seeking, ever moved by the grandeur of a cosmos still in the act of becoming.